People can hear me?
Yes, ma'am.
Yes,
Yes,
right.
ma'am.
Yes, ma'am.
Okay. So the whatever I have saved, okay, that has been gone. Okay, whatever I have written. So I will explain with this only. Okay. So so they have given a problem and they have asked us to find the stoichiometric coefficient. Okay, this is what the problem. So as I told, this is substrate and this is biomass. Okay. So they have given 2/3 of the substrate carbon is being converted to biomass. So for that, first we have to know how much amount of carbon present in substrate. So we have identified 16 into 12, that is 192 grams. And then the amount of carbon converted to biomass is 192 into 2 by 3, that is 128 grams. Okay. And then the amount of carbon, so the remaining amount of carbon is being converted to CO2 only. The amount of carbon converted to CO2 will be 192 minus 128, that is 64 grams. Okay. So now we know how much amount of carbon is being converted to biomass and how much amount of carbon that is being converted to CO2. So what we will do, we will take just the carbon present in biomass and CO2 and equate. So first 128 is present in what? Carbon, 128 of carbon is present in biomass. So 128 is equal to C into this 4.4 into atomic weight, that is 12. That is C is equal to 2.42. And the next is amount of carbon converted to CO2. Okay, and the next is amount of carbon converted to CO2. That is, sorry, amount of carbon converted to CO2 is 64. So 64 is equal to 1 into E into 12. Okay, so we have got C and E. Okay, and now since we have considered the carbon, so we are not starting with carbon balance. We will start with nitrogen balance. Okay, we will start with nitrogen balance. So now nitrogen balance is like we have to consider. So B into 1 into 14. Remember, this is not an elemental balance. This is a material balance. So when you are doing this, you should write the what? Atomic weight also. You should multiply with the molecular weight also. Okay, remember that very clearly. So what you will have is, so we have done the nitrogen balance, material balance, okay, and oxygen balance, and we have found the A, B, C, D and all. Okay, till this we have found in the last session. Okay, so the next what they have asked is, so we have found the stoichiometric coefficient. So just I will write the value over here and then we will go to the next session. Okay, the next, that is yield coefficient, how to find the yield coefficient and all. Okay, so clear with the concept, ma, how to find the stoichiometric coefficient? Clear? Any doubts? If you
No, ma'am.
have doubts before I go to the next session, just ask me, ma. While the time I write this equation, I will explain you. So the clue for finding the stoichiometric coefficients easily, the clue what is given is 2/3 of the substrate. Okay, if it is this 2/3 of the substrate is being converted to biomass, that concept is given, means you will be lucky enough, because what happens is any one of the one or two coefficients you can find easily. Okay, if one or two of the coefficients is being found easily, then it will be easy for you to find the other coefficients. Otherwise, what we have to do means we have to start from carbon balance, nitrogen balance, hydrogen balance, like that. When you are doing each balance, you will get one equation. Okay, and after that you have to solve the equations and then find the stoichiometric coefficients, like equation method. Okay, suppose if this clue is given, so you people should be happy that 2/3 of the substrate, or sometimes they will give it as 3/2 of the substrate also. So you should remember which is being asked. Here it has been given as carbon. Sometimes they may give us hydrogen also. Accordingly, you people should change. Okay, and usually out of this no other problems will ask. Usually whatever the problems we have solved only will be known. And another one thing is, you people should know this equations. Okay, whatever the equations here we are studying, you people should know this equations also, because they will sometimes they will ask, calculate the stoichiometric coefficient and find the yield coefficient and degree of reduction for the process of hexadecane formation. So at that time, you people should know the equations, whatever the problems we are studying here, and you people should know the equation also. Okay, So now stoichiometry coefficients is being done. Okay. So according to that, what is the values is C is equal to 2.42. Okay. C is equal to 2.42. And the next we have found E. E is equal to 5.33. And then B is equal to 2.085. Okay, B is equal to 2.085, and then D is equal to 11.29. Okay, D is equal to 11.29, and then A is equal to 12.427. Okay, A is equal to 12.427. Now what we have to find is yield coefficients. That is what they have asked is Y x bar s. Okay, and then Y x bar O2. Okay, x bar s and Y x bar O2 is being asked. Okay, Y x bar s and x bar O2 is being asked. Okay, so x bar s, what is x is the amount of biomass formed divided by the amount of substrate consumed. Okay, so how will you write this? C into C 4.4. Okay, so you people know what is C. Okay, that is 2.42. Okay, so 2.42. So remember this coefficient also you should consider. Okay, so C, that is 2.42 into how much amount of carbon? 4.4. This is biomass. X represents biomass. Remember, okay, always X represents biomass and S represents substrate. Okay, S represents substrate. 4.4 into 12 plus 7.3 into 1 plus 0.8 into 14. Okay, plus 1.2 into 16. Okay, 1.2 into 16 divided by, okay, substrate is what? C16H4. So coefficient is what? 1. Okay, 1 into, why I am writing this 1 also? Because we should not forget to write the coefficient. 16 into 12 plus 34 into 1. Okay, plus 34 into 1. So how much you will have is, so 0.98. When you solve this, you will get 0.98. The unit is, okay, gram of cells. Okay, this is biomass means nothing but cells. Okay, gram of cells by gram of substrate accordingly. Okay, gram of cells divided by gram of substrate. And here again what they have asked is, okay, so Y x bar O2. Okay, so this numerator will remains the same only. Okay, the numerator will remains the same, that is 2.42 into x is again what? Substrate, sorry, biomass. So 2.42 into 4.4 into 12. Okay, that will remains the same. So here denominator they have asked us O2. Okay, that is O2. So A, what is A here is 12.427. Okay, A value is what? So 12.427 into what? 2 into 16. Okay, this is atomic weight. 2 into 16. So how much you will get is Y x bar O2 is, you will get 0.557. Okay, 0.557. And they have asked again degree of reduction. Okay, degree of reduction of substrate. Okay, degree of reduction of substrate. So if simply degree of reduction is asked, you have to take the substrate only. Okay, degree of reduction of substrate. So degree of reduction of substrate, I have told this is gamma. Yes, if it is biomass is being asked, you will write gamma B. Okay, Since it is asked as gamma S, okay, substrate, we will be writing as gamma S, okay. So I have told you this is not the elemental balance, sorry, equivalence, okay, not the atomic weight. Degree of reduction, you people should remember, okay, degree of reduction is then 16 into multiplication, usually we will do with atomic weight, so here is equivalent, okay. 16 into 4 plus 34 into 1 divided by number of gram atoms of carbon, that is 16, okay, number of gram atoms of carbon, that is 16, 6.125. And the next they have asked this respiratory quotient, okay, that is RQ. So what is RQ is the moles of CO2 consumed divided by the moles of CO2 produced divided by the moles of oxygen consumed. So here the moles of CO2 produced is E and the moles of oxygen consumed is A. So that is E by A. It is E is what? 5.33 divided by A is what? 12.427. Okay, A is 12.427. Clear? So the answer is respiratory quotient is 0.428. Okay, the respiratory quotient is 0.428. Clear, ma? So this is all about this problem. So first we have taken whatever has been given as 2/3 of the substrate. We have found amount of converted biomass, substrate converted to biomass and CO2. And then we have taken that amount and equate to the carbon present in biomass and CO2. And we found this stoichiometric coefficient C and E. Okay. And then again we have done the high, because already carbon has been converted, so we have started from nitrogen, hydrogen, oxygen balance and all, and found all the other stoichiometric coefficients. So first section is done. Then the yield coefficient, remember always X is biomass, S is substrate. So here given oxygen also. Any doubts, ma? Any doubts? So O2 is also been given. Sometimes they will give depending upon the data given. You people should suppose if it is X by NH3, you have to take the NH3. Okay. So like that. And the degree of reduction, remember, so you should not multiply with the molecular atomic weight. You should multiply with this equivalence. Okay. And then respiratory quotient, that is E by A. Okay. That is moles of CO. Always this formula will remains the same. Moles of CO2 formed by moles of A consumed. Okay. So now this is what the first same type. Another one problem is also been given. Okay. So I will show that and you people have to do that problem as homework. Okay. We'll just, so the glucose is, the equation is same method. Okay. How we have done the same method, but this is for glucose. C6H12O6 plus AO2 plus BNH3 gives C into C4.4 H7.3 N 0.86 O1O2 plus DH2O plus ECO2. Okay. So same you people have to do. So if you, so how we have to do means, first let me write fastly, I will do this. Okay, problem also. So what is the formula is, okay, C6 same problem, same method, but the this is glucose production. Okay, C6, sorry, not glucose. Glucose has been converted, that is hexadecane has been converted to biomass. So here glucose has been converted, C6H12O6 plus AO2 plus, usually this AO2 and BNH3 will be the same. Okay, BNH3 gives, okay, C 4.4 H. And this week I will be finishing the module 5. Okay, small module N 0.86 O 1.2 plus DH2O plus ECO2. Okay, so now first we have to convert how much amount of carbon. So I am not writing that left hand side. First what will be present is, so same condition, 2/3 of the carbon biomass substrate has been converted to biomass. So how much amount of carbon present is 6 into 12. In 1 mole of substrate is 6 into 12. Okay, that is 1 mole of substrate. 6 into 12, that is 72 grams. Okay, next step, tell me ma, what we have to do? So the amount of carbon present in substrate is what? 72 grams. Now amount of carbon converted to biomass we have to find. That is 72 into how much? 2/3, right? 72 into 2/3. So that is 48. Okay, 72 into 2/3, that is 48 grams. Now the next is amount of carbon remaining should be converted to CO2. So the amount of carbon converted to CO2, okay, is equivalent to 72 minus 48. So that is 24 grams. So next is this, okay, 24. Now this carbon we should equate it to here. So only carbon. So amount of carbon in biomass is 48. So here this is substrate and this is biomass, right? So 48 is equal to C into 4.4 into 12. Okay, C into 4.4 into 12. So we will get as C is equal to 0.909. Okay, C is equal to 0.909. And then next is what? 24. Okay, so 24 is equal to so here, so E into 1 into 12. Okay, E into 1 into 12. So what you will get as E is equal to, when you solve, you will get E is equal to 2. Okay, so now as usual we have to go for so already carbon has been done, so we will go with nitrogen balance. Okay, so we will go with nitrogen balance first. Okay, so how will be, so first is nitrogen balance. So nitrogen balance is B into, so okay, B into 1 into 14 is equivalent to, I will just tell ma. So B into 1 into 14 is equivalent to, okay, C into 0.86 into 14. Okay, C into 0.86 into 14. So you will get C as 0.909. Okay, CS 0.909. And the next what we will do is hydrogen balance. Okay, next we will do for hydrogen balance. So as I told, 1 into 12 into 1. Okay, that is C6H12O6. 1 into 12 into 1 plus B into 3 into 1 is equivalent to C into, sorry, 7.3 into 1 plus C into 7.3 into 1 plus, whether Mamta ma'am had sent the request ma for next class?
No, ma'am.
No, ma'am.
Right, so I can continue,
Send the
right?
picture.
Yes, ma'am.
So plus 2d into 2 into 1. Okay, d into 2 into 1, right? So d into 2 into 1. So here you will get the value as d. Okay, d value you will get. So d value you will get as, so do it ma and find out 3.855. Okay, 3.855. And the next is a, we have to find a, so we will go for oxygen balance. So that is 16, sorry, 6 1 into 6 into oxygen is how much? 12 plus then A into 2 into 12. Oxygen is 12 or 16 ma? Sorry, 16, right? Oxygen is 16. A into carbon is 12, oxygen is 16. A into 2 into 16 is equal to again C into 1.2 into 16 plus E into 2 into 16. Okay, so now we will get as A is equal to 1.473. Okay, A is equal to 1.473. Next we have to find, so the stoichiometric coefficients has been done. So now next we have to find y of x bar s, that is substrate by biomass. Okay, so y bar x bar s, when you do it, x bar s is what? C into 4.4 into 12 plus 7.3 into 1 plus 0.86 into 14 plus 1.2 into, okay, so C into the whole equation will come divided by S is what? Substrate. Okay, so here you will have 180. So here when you do that, okay, all of you do it, you will get 83.02 divided by 180. Okay, divided by 180. 83.02806 you will get. Okay, so you will have the answer as 0.461. Okay, 0.461. And the next is y x bar O2. Okay, they like same x bar O2. So now x is same. This O2 is what? AO2. A into 2 into 16. Okay. So when you do that, you will get the answer as 1.7614. And the next is degree of reduction of what? Substrate. Okay, degree of reduction of substrate. As I told, for this you people should always remember not the atomic weight, it is the element. So 6 into 4 plus 12 into 1 plus 6 into minus 2 divided by number of carbons is 6. Okay, so you will get the answer as 1.7614. This is 7. Okay, 1.7614. And the next is RQ, that is respiratory quotient. So respiratory quotient is what? The amount of CO2 consumed divided by the amount, sorry, CO2 produced divided by the moles of oxygen consumed. It is again here same E by A. Substitute the values. Okay, so you will get 1.357. So clear, ma? So the concept is clear, this type of problem. So we have some 3 different types of problems for stoichiometric balance. So this is the first type of problem for finding the stoichiometric balance. So sorry, for finding the stoichiometric balance. That is, if they give the 2/3 of the substrate is been converted to carbon. So how we have to find? First we have to find how much amount of carbon is being present in substrate. Then how much is converted to biomass, how much is converted to CO2. Then we have to equate biomass to the carbon present in biomass, amount of carbon. Okay, and find the first stoichiometric. Then to CO2, then nitrogen balance, hydrogen balance, oxygen balance, step remains the same. Then X bar S, X bar O2, and then what? Only degree of reduction you should remember. Okay, and all the other things are same. Clear? Yes or no, ma? Clear?
Yes, ma'am.
So this is what, okay, again for this, for glucose, okay, we have done this stoichiometric coefficient, so amount of carbon converted to CO2, then nitrogen balance, oxygen balance, okay, and then hydrogen balance, and then this yield coefficients together for all the problems. Okay, I have given writing portion I have told, so follow that. Okay, yield coefficients. So this type of set of problem is being done. Okay, another 2 set of problems, so by Wednesday I will finish that. Okay, and within this week we will finish this module 5. Clear, ma? Yes or no? The concept is clear
Yes,
for
ma'am.
this. Okay, so I will just stop
Yes.
the
Yes,
record.
ma'am.